Hi everybody. Today we're going to talk about quadratic equations. The whole point of college algebra is to teach us how to solve various kinds of equations. Okay, a lot of times people are like, why do we have to learn this? What's the point of it? College algebra in itself, really, there is no point to it for your lives, but it helps us in our future math classes. So college algebra gives us the tools to solve various kinds of equations that we're going to run into in our future courses and future studies. So what's really important to recognize is that we need to know what type of an equation we have when we see one, because depending on the type of equation, that tells us the method of solving it. Okay, linear equations are the most simple kind of equations, and you should already be very familiar with linear equations. Just for a second, let's do an example of what a linear equation is. A linear equation would be something like this, right? Where your biggest exponent is a 1. A quadratic equation, your biggest exponent is a 2. And that's what we're going to focus on today. Here's the generic form for a quadratic equation, where of course A, B, and C would be numerical values. Okay, here's some examples down here of different quadratic equations. First of all, we got to make sure they are an equation. I got to have that equal sign. An expression cannot be solved. Don't forget that. An expression cannot be solved. Equations we can solve. A lot of times someone will see an expression and they will add equals 0 and feel like, now they have an equation to solve. You cannot add an equal sign or take one away. So linear equations have one method of solving them. As a matter of fact, let's just review that method because it's going to help us with one type of our quadratic equation. Remember, if we have a linear equation, our purpose is just to get the variable on one side of the equal sign and the numerals on the other. So I can subtract 3 from both sides as long as we do the same thing to both sides of the equation, right? Then we get equivalent equations. So now that's 0, and we wind up with 2x equals 1, and then we undo whatever's being multiplied to the variable. Same thing on both sides, until finally you have the x all by itself on one side of the equal and the numeral on the other side. Okay, so that's the basic steps for solving a linear equation. If you're not well versed at already solving linear equations, you need to go back and practice that. We're not going to take the time in this course to do that. You should have done that a ton in your previous algebra classes. Okay, so this form right here, or this one right here, is what's called standard form. So also pay attention to that, right? If you have it in standard form, it's where it equals 0, and sometimes we're going to need and be requested to put our equation in standard form. Okay, there are 4 methods for solving a quadratic equation. We've got the square root method. This is used when there is no linear term. Linear meaning when your exponent's a 1. So that's like that one we saw on the previous page where it looked like this. Okay, or it could have looked like this. In other words, we don't have that extra x value. Okay, so that's the first thing I'm going to do. I'm going to look to see, I know it's a quadratic equation because I've got an exponent of 2 and no other exponent that's larger. But after I recognize that and the fact that it's an equation, don't forget, okay, then I want to see if it's got that linear term, that extra x term. If it doesn't, I'm using the square root method, right? It's by far the easiest, but that's the only time I can use the square root method. And the square root method is exactly like solving a linear equation. because all I have to do is get the x on one side, which I can do if there's not an extra term with an x. Okay, do the same thing to both sides of the equation, and we've got it solved. Okay, now, if this equation were written like this, I could also use the zero factor property. In other words, set it to 0, which I have it set to 0, and try to factor it. This equation factors as x plus 5, x minus 5. Remember, if you are not excellent at factoring, factoring is the single most important thing. You got to be able to do well to succeed in this course, right? You got to be able to, if you cannot factor extremely well, you need to work on that, right? There's some just-in-time factoring problems in your MyLabs Plus to help you with that. Get some tutoring, ask me, whatever you need to do, but you got to be good at factoring. Nearly everything we do in this course, at some point, and sometimes 3 or 4 times in one problem, we're going to factor it. Okay, now we factor it. Now we factor it. As a matter of fact, I tell my students, so now I'm telling you, that if you don't know how to start a problem, or you get stuck in the middle of a problem, always ask yourself, is there something I can be factoring? Because 95% of the time, that's going to be your answer. That's how you're going to continue the problem or begin the problem. Factoring. We use it for lots of things. So if I factor this, and then the zero factor property tells me if you have 2 things multiplied together that equals 0, the only way that can happen is if one of these things is 0. So either x plus 5 is 0 or x minus 5 is 0. Notice then that gives me 2 linear equations, okay, which linear equations we can easily solve. All right. Okay, but let's take a minute and look at this. This equation is this same equation. All I did was add 25 to both sides, right? These are 2 identical equations. But if I solved it by factoring, I got 2 answers. If I solved it by the square root method, I only got 1. Which means I'm not completely finished with this square root method. On linear equations, if your biggest exponent is 1, you'll always get 1 solution. Well, I mean, you could get no answer or an infinite number of answers, right? I guess that's always an option. But as far as numerical solutions, you'll get 1. When you have a quadratic equation, in other words, if your biggest exponent's a 2, you'll always get 2 solutions. When we get to cubic equations and your biggest exponent is a 3, we'll get 3 solutions. When our biggest exponent is a 5, we'll get 5 solutions. So I really do need both of these solutions. When we do the square root method, and this is the most commonly forgotten thing, so make a note of this somewhere. Whenever you take the square root, we have to add a plus or minus, right? A plus or minus. Because think about this. The square root of 25 is also technically negative 5, because negative 5 times negative 5, positive 25. Okay, so we need to remember to add that plus or minus anytime we take the square root, anytime. Okay, so then, oh yeah, I've got the same 2 answers. Okay, then we've got something called completing the square, because sometimes we get quadratic equations that won't factor. So I need another method of factoring them. Okay, that's completing the square. We'll talk about that. It's a bit of a process. Here are the steps listed. So you might make a note of these steps or, copy the slide, whatever you want to do. And then after completing the square, we have the quadratic formula. Its use is if you try to complete the square and it's made difficult by fractions, then we can just plug into the quadratic formula. Okay, so here's the quadratic formula that A, B, and C are the actual numerical values whenever our quadratic equation is in standard form. Okay, so we're going to do some examples of all of these. You might want to make yourself a note of these steps. And by the way, the way I have them listed here is your thought process that you should go through as to how you should solve them, right? First, you should see if you can use the square root method. If you can, that's by far the method you should use. Second, if you can't use the square root method, you should see, can I do the zero factor property? Will it factor? You got to set it to 0 first. If it won't factor, then you should try completing the square. If completing the square gives fractions, which makes it a little bit difficult, then last, you should use the quadratic formula. The problem with the quadratic formula is people say, oh, I've got a formula, I'm just going to plug into the formula and use it, which you can, but over half the time, it makes your work a lot more difficult. It's best to use as a last resort. Okay, so let's try some examples of these. All right, now on these first ones also, you'll notice that the instructions kind of give away your method. I'm going to ignore that, and we're just going to say, what's the thought process I should go through to try to solve this? Okay, first thing, I got to have an equation, and then it's got to be a quadratic equation. So my first thought is, hey, can I do the square root method? That means it can't have that extra x linear term. Oh, I can. So, okay, here's the steps. You might want to write this under, if you made a list of those 4 steps, write this under the square root method. Move everything that is not the square term to the other side of the equation. In other words, let's start with this one, since we have that step to do. This one, it's already performed for us. This one, it's already performed for us. So right here, first step, before you can use the square root method, move the non-square terms to the other side of the equal sign. So now this is a big fat 0, 17 minus 17, and just leaves x squared equals negative 17. Once you have the square term isolated all by itself, then you're going to take the square root of each side, right? Of the entire side, square root of each side. Now this square and that square root, they undo each other to leave a plain x. And don't forget, if you've got a negative under a radical, it has to come out as an I, and then you have the square root of 17 left. Okay, anytime you do the square root of a numeral, you must remember to add that plus or minus, because I got to have 2 values for a quadratic equation solution. Don't forget to check that radical to see if it'll simplify, but in this case that 17 will not. So there's our 2 solutions. Positive I squared to 17, negative I squared to 17. Okay, by the way, your MyLabs Plus, I believe it puts up brackets, and then it just asks you to enter your answers like this. Why they do not put that plus or minus symbol in there, I don't know. It's really annoying. But, you know, if you're not in MyLabs Plus, you can just use that plus or minus. But that's how your answer is going to look entered in MyLabs Plus. Okay. Here's another, and I can use the square root method on because it doesn't have that linear term. So I've isolated the square, okay, and then you take the square root of both sides. That means this square and that square root will undo each other, just leaving an x. Anytime you do the square root of a number, don't forget your first step, plus or minus. And then square root of 9 is 3. Okay, over here, the square term, now notice it doesn't have to be one value, but since the square is on the parentheses, that means this whole thing is being squared. So make sure it's isolated on one side of the equation. Take the square root of both sides. That means this square and that square root will undo each other and just leave 4x plus 1. Now, what do you have to write first? That's right, plus or minus, right? Okay, plus or minus, and then we have square root of 20. Don't forget, I always have to see if any radical, it's just like a fraction, if any radical can be simplified, it has to be, goes without saying. So I notice that I can change that 20 to 4 times 5. Now the reason I want to do that is because I can actually do this square root of 4 part, right? So that will simplify as 2, because square root of 4 is 2. And then the square root of 5, that's a multiplication, right? Not a minus. So square roots of 5. Now, it doesn't matter how crazy bits of your numerals look. The only thing in here that's a variable is this x. Everything else is some numerical number. You could plug that on your calculator right now and get a number, right? So this is now a linear equation. And all I have to do is get the x all by itself. So I'm going to subtract 1 from both sides. That makes this a big fat 0. So I just have 4x equals, now these are different terms, they won't combine, so negative 1 plus or minus 2 square roots of 5. Okay, now to get this x all by itself, I need to divide by 4, entire side, right? You could do individual terms if you want, or entire side, but you got to do the whole thing. So now these 4's divide out, and finally I'm left with just an x equals negative 1 plus or minus 2 square roots of 5 all over 4. Square root method. All right. Let me know if you have any problems. Square root method. We're going to actually, in the midst of completing a square, we do the square root method as part of that, so we'll practice this some more. Okay. Now, I notice on these, again, first thing I've got to notice is that, oh, hey, it is a quadratic equation. They're both quadratic equations, all right? So really, that's our first thing. So when I notice that, first, can I do square root method? No. This is why I cannot do the square root method on either one of those. It has that extra linear term, just an x to 1 power, right? Okay, so then my second thought is, well, I'm going to set it to 0 and try to use the 0 factor property, or sometimes you'll hear it as the 0 product property. In other words, I'm going to try to factor it. So first step is I'm going to set this thing equal to 0. Subtract 3 from both sides. Okay, now, like I said, you should already be well versed at factoring. If you don't know how to factor, you need to see me, you need to get some help, you got to learn that. So we're not going through the steps of factoring. We're going to say, let's factor this thing. Okay, so in my method, there's lots of methods. Whatever you have that works for you, you do. My method is I find two numbers that multiply to give negative 18, right? So they're going to multiply and give negative 18, and they're going to add to give 7. So those two numbers are 9 and negative 2. That means we can rewrite this problem. There's also a shortcut if you're interested in that. We can rewrite this problem as 6x squared minus 2x plus 9x minus 3. And then factor it by grouping. Okay, so factor out of 2x. That leaves 3x minus 1, factor out a 3, that leaves 3x minus 1. Whatever your factoring method is, and eventually you should have 3x minus 1 times 2x plus 3. Okay. Now, here's our zero factor property. After we factor it, we wind up with two things being multiplied together that equal 0. The only way that you can multiply two things together and get 0, and by the way, it only works with 0, right? Just because I multiply two things together and equal 3 does not mean one of them's 3. It could be 1/2 and 6. It could be -3 and -1, right? Only works with 0. Then one of those is 0. So I know that either 3x minus 1 is 0 or 2x plus 3 is 0. Now we have simple linear equations that we can solve. Right, so solve your linear equation to get x equals 1/3. And notice we will have two solutions. And x equals -3/2. All right, let's try it again. This one is already set equal to 0, so I'm good with that, but when I'm factoring, I don't want a negative sticking out front here. So I'm going to go through, and you can either think of it as multiplying everything by -1 or dividing everything by -1, right? Just got to get rid of that negative on that leading coefficient. So that would make it positive 2x squared minus 4x minus 3 still equals 0. 0 divided by -1 or multiplied by -1, still 0. All right, I'm going to try to factor it. So my question is, are there two numbers that multiply to give -6 while at the same time adding to give -4? Okay. So they gave us one on this example for using a zero product property that doesn't factor, guys. Interesting. Okay. 6, double check. 6 and 1. 2 and 3 are only options. Nope, doesn't factor. So just for the sake, sorry about this, it's a prepared slide. Just for the sake, so we can continue our thing, let's make this thing factor. Let's change this 4 to a 5. All right. All right, so now let's go through that process again. I still don't want this negative out front here. So I have 2x squared now minus 5x minus 3 equals 0. So I'm looking for two numbers. I need them to multiply and give -6 and add and give -5. So now I can actually find two numbers that happens. Now if it doesn't happen, if we had that original equation like it just gave it to us, we'd go to our next step, right? Okay, it doesn't factor. They don't always factor. But since we're practicing the factoring one, let's make it factor. Okay, so if I add them together, I get -5. So those are the numbers I need. So I can rewrite that -5x as -6x plus 1x, right? Still -5x. And then it'll factor by grouping. So I can factor out a 2x, which leaves x minus 3. If there's nothing else to factor out, remember there's always a 1, and that leaves x minus 3. Now the x minus 3 can factor out, and we're left with 2x plus 1. Okay, So whatever factoring method you use, and we're not teaching factoring now, but if you need help with it, I'll say it one more time. I might say it 10 more times. Let me know, right? Okay, but once we get it factored, by whatever method we prefer, we'll wind up with two binomials multiplied together that equal 0. The only way that can happen is if at least one of them equals 0. So I'm going to set them each equal to 0 and then solve those resulting easy linear equations. So we get x equals 3 for one solution. And pretty soon, we're going to quit writing this step too. We should just be able to jump to, once we see 2x plus 1, try to get used to knowing that, oh, that means your solution is x equals -1/2. Because, think about what steps we're doing here. So 2x equals -1 divided by 2, x equals -1/2. And there's our two solutions. All right. Now, completing the square. So, first of all, they're both quadratic equations. Don't forget to make that note. Depending on what kind of equation it is, depends on our methods. And because they're quadratics, then I need to see if I can use the square root method. Nope, can't use the square root method. So I'm going to see if it'll factor. Notice how quick it is to see if it'll factor. That means, are there two numbers that multiply to give -14 and add to give -4? That's my question. No, the only thing that multiplies to give -14, now let's just say 14. 2 and 7, can't combine them for 4. 1 and 14, nope. Can't use the square root method. It doesn't factor. Next step, completing the square. Okay, completing the square is a process. You should have a list of those steps from that previous slide written somewhere so we can follow them. First step on completing the square is make sure that you move this constant term to the other side of the equal sign. Right? So I'm going to add 14 to both sides. Second step, make the leading coefficient 1. Now in this problem it already is 1, right? Over here we'll see an example of what to do when it's not 1, but make it 1. Now I'm going to take half of this middle term here. And I know that we know half of 4 is 2, but sometimes if we have a problem like over here where we're going to have 3/4, and we're like, oh, what's half of 3/4? You can always find that by saying half of means multiply, right? Half of 4, right? So you go over to the side and you multiply half by whatever term you have there. And when we simplify this, we realize we get 2. Okay, so I'm going to take that number and then I'm going to square it. That's the number I'm going to add to both sides. So I'm going to have a +4. Both sides. Got to do the same thing to both sides, right? Now, that makes this a perfect square trinomial. Remember, you got to know about your factoring properties already. So I don't have to even think about how to factor that, because sometimes it's going to be hard to factor, but I'm going to know. That's the reason I choose these particular numbers, that it's always going to be x, it's going to use this sign, and this first number we got up here, that half of number, all squared. And then the other side of the equation is 18. Voila! Now we use the square root method, right? Square root method. So take the square root of both sides. That's going to undo itself and leave just x minus 2. Don't forget, what's the first thing you do when you take the square root of a number when it's in an equation? Plus or minus. And I'm going to change that 18 to 9 times 2 because 9 is a perfect square, right? So we wind up with x minus 2 equals plus or minus 3 square roots of 2. The 2 just has to stay under that radical. Again, we've got a linear equation. this is our only variable. So if I add 2 to both sides, I have 2 plus or minus 3 square roots of 2, and there's my 2 solutions. 2 plus 3 square roots of 2, 2 minus 3 square roots of 2. Okay, on this one over here, first step, as before, is I've got to move that 10 to the other side of the equal sign. So add 10 to both sides. Add 10 to both sides of the equation. And then, second step, make the leading coefficient 1. In this case, since it's not 1, all I have to do that is just divide everything by that coefficient. Okay, so now that's going to give me a 1x squared minus 3/4 x equals 10/4. Okay, second step, well, third step, I guess. Third step, take half of 3/4. Oh my goodness, what is half of 3/4? I don't know. Half of 3/4, right? Half of 3/4, multiply straight across, 3/8. Oh, not too bad. And then square it. 3/8 squared is 3 times 3, 8 times 8, 9/64, right? Add that to both sides. Let me, oh shoot, I didn't mean to erase the whole thing. All right, let's start over. All right, so we've got to add 10 to both sides. We've got to make the leading coefficient 1. We've got to take half of that linear term, so half of 3/4 is 3/8, and we've got to square it. Now we add this to both sides of the equation. Right, both sides of the equation. That makes this a perfect square trinomial, which I know how nasty it looks to factor, but the reason I chose these particular numbers is because now I automatically know how this factors. Every single time I'm going to know how that factors. It's going to have x. We're going to take this sign and this first number that we got over here, the 3/8, all squared. Okay, now I'm going to add these together. To add fractions, I need a common denominator. So what's this going to be? Times 16 to be 64. Whatever you do to the numerator, same thing to the denominator. So that we will then have 160 over 64 plus 9 over 64. So 169 over 64. All right, now we're going to square root both sides. Now that it's set up to use the square root method, square root, square root. That means this is going to cancel, and we're left with x minus 3/8 equals, don't forget your plus or minus, right? Plus or minus. Square root of 169 is 13. Square root of 64 is 8. Linear equation. All we have to do is add 3/8 to both sides. Now, I've got a plus or minus, so notice this is really two numbers here. So I'm going to have x equals 3/8 plus 13/8. And x equals 3/8 minus 13/8. And I've got to separate that. and get my two separate values. Yeah. They've got common denominators, so all I got to do is add those numerators. So this is x equals denominators 8, 3 plus 13, 16, 16 divided by 8, so x equals 2 for one solution. Or over here, denominator's 8, 3 minus 13 is negative 10, so negative 5/4 for the other solution. Okay, completing the square. I'm sorry that I erased this over here. I wanted us to see, look at the difference in how easy this one was versus this one. What made this so complicated was that it involved working with fractions, right? Made it complicated. If there are no fractions involved, completing the square is really easy. If there are fractions involved, then ideally, once I notice that if any of, when I divide by 4, if that makes a fraction, I'm thinking, oh, then I'm going to move to my next option, which is quadratic formula. Usually, 99% of the time, if completing the square is easy, quadratic formula is hard. If completing the square is hard, quadratic formula is easy. Sometimes they're long no matter which way, that they're both long, but the vast majority of the time, that's true. So let's look at now, here's another completing the square. So that's good to have another example of that where we have fractions, because that's a little bit tough sometimes. Okay, and sometimes you'll be asked to do completing the square just because we need this method down for later. We're going to do completing the square when we get to circles, and we're going to be doing 2 completing the squares and 1 problem. So we really need to know these steps, right? So don't think you can just, I don't really need that. I'm just going to do everything with quadratic formula. No, we won't be able to use that quadratic formula on circles. We'll have to complete the square twice in 1 problem. So I need to get these steps down. Okay, first step, subtract 9 from both sides. In other words, just move that constant term to the other side of the equation. Okay, make the leading coefficient 1. So I'm going to divide everything by 9 to get 1x squared. These are both divisible by 3. So mine is 4/3 x equals -1. Take half of this term. So half of 4/3. Hey, look, this'll, this one we should have known. Half of 4/3 is 2/3. Makes sense. And then square it. 2/3 squared is 4/9. Okay, I'm going to add that number to both sides. Got to do the same thing to both sides. Okay, now that makes this a perfect square trinomial, and I automatically know how it factors. I don't have to waste time working on factoring it. It uses whatever signs. So far, all these problems have had a minus there. Don't mistakenly think this is always a minus. It uses whatever sign is right here. And then it uses this number, all squared. That's a 3. I've got to add -1 and 4/9, so maybe I want to make this a fraction with a denominator of 9. Let's make it 9/9 so that we can easily do that. They both have a denominator of 9 now. -9 plus 4 is -5. And now I can use the square root method. All right? Square root both sides. And then this will undo itself. and just leave x minus 2/3. Don't forget your plus or minus. Don't forget your I. Okay, I can't do the square root of 5, so I'll just leave it. But the square root of 9, I can make a 3. Okay, now, linear equation again, so I'm just going to add 2/3 to both sides. Okay, so x equals 2/3 plus or minus I square root of 5/3. This is fine if you want to leave it like that, or you might notice they have the same denominator, or you could make them the same if you're going to combine fractions. And once you get the x all by itself equaling only a numerical value, you've solved it, and you have two of them. All right. All right, now this one asks you to use the quadratic formula. But still, we're going to go through the process. I cannot use completing the square. Okay, I'm going to see if it'll factor. Okay, in order for me to see if it'll factor, it's got to be equal 0. It's got to be equal 0 anyhow to use the quadratic formula. So that's no problem. Just add 2 to both sides. Okay. Now, it won't factor. There's not two numbers that multiply give 2 and add to give -4. Okay. In reality, this is a completing the square one. So let's look at the difference in using completing the square versus quadratic formula on this one. If I'm going to use the quadratic formula, first of all, maybe we'll write it up here just to remember it. X equals -b plus or minus the square root of b squared minus 4ac all over 2a, where these numerical values, whenever it's solved for 0, are a, b, and c. Right? No x's ever go over here, only numerals. All right, so I'll just plug into the quadratic formula. X equals -b, so -4 plus or minus the square root of b squared. Watch your notation. If you just write -4 squared, that's not correct, right? This gives +16. Without the parentheses, it's -16. So careful on our notation. -b plus or minus b squared minus 4 times a times c all over 2 times a. And then we just got to simplify all these numerical values over here. So we've got 4 plus or minus the square root of 16 minus 8 all over 2, okay, which is 4 plus or minus 16 minus 8 is 8 all over 2, which is 4 plus or minus, now I got to simplify that, 8. So we wind up with 4 plus or minus 2 square roots of 2 all over 2. And then I can factor a 2 out of each one of these. To finally get my answer. Let's do that right quick just by completing the square. All right, the number's already on the other side. I'm going to take half of 4. Half of 4 is 2. 2 squared is 4. Add that to both sides. I know how this factors. It's a perfect square trinomial. This sign, the half number, so 2. Use the square root method. Square root both sides. Add 2 to both sides. Ta-da. Okay. All right, I'm going to get rid of all this so we can work on this one. Okay, since we're told to use the quadratic formula, we're just going to jump right to it. Okay, this actually is a quadratic formula one anyhow. Well, let's see why. First of all, it needs to be set to 0. Okay, so 2x squared minus x plus 4 equals 0. Can't do the square root method. It won't factor. There's not 2 numbers that multiply to give 8 and add to give -1. And if I make this 1, I've put a half right here. So I really don't want to do completing the square either. This is legitimately a quadratic formula problem. Let's do it. Now remember, this is A, this is B, which is -1, and this is C. So x equals negative b, so negative, -1, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So x is 1, plus or minus the square root of 1 minus 8 times 4 is 32, all over 4. X is 1 plus or minus the square root of -31, all over 4. Can't have that negative under a radical. That 31 won't simplify any further though, so then I'm finished. A nice quadratic formula problem. Okay, let's see what else we got. Okay, great. Just solving some equations now. Okay. So, first step, make sure that it is an equation and it's quadratic. I'm going to get rid of those fractions, just like we did in a linear equation. Hopefully you remember that your first step in any equation, get rid of fractions. Do not even try to plug these fractions into the quadratic formula. No, just get rid of the fractions. To get rid of the fractions, remember we need the LCD. So the LCD between 2 and 4 is 4. Just multiply everything all the way across by that 4. Okay, so then 4 divided by 2 is 2. 4 divided by 4 completely cancels, so we're left with 2x squared plus 1x minus 12 equals 0. Well, I can't use the quadratic formula. I can't use the square root method because of this right here, so I'm going to try to factor. Are there 2 numbers that multiply and give -24 and add to give 1? Well, I've got 2 and 12, nope. 4 and 6, nope. 8 and 3, nope. 24 and 1. It doesn't factor. If I divide by 2, it's going to make a fraction. This is another quadratic formula one. So x equals -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times 8. So x equals -1 plus or minus the square root of 1. Now what do we have here? 8 times 12, 96, plus, because there's 2 negatives, all over 4. So -1 plus or minus the square root of 97 all over 4. I got to check that 97 and see if it'll simplify, but it won't. Notice how we chose the quadratic formula as the appropriate method, and it's pretty easy. Now this one, they're trying to be tricky. Don't let them trick you. It doesn't matter that it's factored. The only way that helps you is if it equals 0. So really, by them factoring this for us ahead of time, it just caused us extra work. I've got to multiply this out. So x squared minus x minus 9x plus 9 equals -16. Now, I'm going to combine all my terms and set it equal to 0 again. So I've got x squared minus 10x. And if we add 16 to both sides, add 16, we have 25. And if I'm good at factoring, I should recognize this as a perfect square trinomial. And it's one of my special factoring methods, right? Otherwise, I can still look for 2 numbers that multiply to give 25 and add to give -10. Notice they're -5. So we get x minus 5, x minus 5. Okay, so I factored it. Here, really, I could use the square root method, or I'm already basically finished. X minus 5 equals 0. X minus 5 equals 0. So add 5 to both sides, and I get x equals 5. Now, notice it's the same number, but I still have 2 solutions. I don't have to write it twice as my answer. I can just write x equals 5, but I do have 2 solutions where x is 5. Okay, look at this one. This one's actually a cube, which later we will have cubic equations that won't factor, so that takes a whole different method. But notice the instructions on this one: solve using factoring. If you're giving a cubic equation in this set of problems, it'll factor. Here's just another reason why we need to be able to factor. All right, so hopefully we know to factor cubes, you put the cube root of each term in your first factor, and then you square the first one, you add them together. Well, don't add them together, you multiply them together, and you square the second one. Okay, your signs are the same, opposite, always positive, SOAP. Again, that's all factoring methods. If that loses you on how I factored that, you got to go somewhere and learn how to factor. Learn all your factoring methods. Okay, so now I have 2 things multiplied together that equal 0. That means at least one of them is 0. So either x plus 2 is 0, or x squared minus 2x plus 4 is 0. This one's easy. This is a simple linear equation, so we know right away that x is -2. But now notice this one's a quadratic equation that I can't use the square root method on. It won't factor. Oh, I know it says use the quadratic formula, but no, this is a kind for completing the square. Quadratic formula would be a giant pain like that first one we did. Let's do completing the square. Okay, so first step, let's move that 4 to the other side of the equal sign. Leading coefficient is already 1. Let's take half of 2, which is 1, and square it, which is still 1. Add that to both sides. That makes this a perfect square trinomial that we know how it factors. It's going to have this sign and use that first half of number, which in this case, both of them are 1, all squared. -4 plus 1, -3. Square root method. This is cancel. Okay, so x minus 1, and what do we need right here? That's right, don't forget your plus or minus. Got to get that negative out of there and make it an I. And then solve for the x. All right, so you've got a couple of cubes, but it's only because they're cubes that will factor. If they will not factor, we got to have a different method for it, which we'll talk about later. Okay. What if we have an equation that has more than one variable in it, and we want to solve for a specific variable? That means we have to be told which variable to solve for. In other words, right now, it's a formula. It's solved for A because it says A equals this stuff. All we want to do is rearrange. We can't get a numerical answer, right? Because I've got more than one variable. Notice all those problems we've done in this whole section. They were all always an X. They could have been P's or Q's, but they had to be the same variable in the same problem, or these methods wouldn't have worked. So here I can't solve for a numerical answer, but I can solve, just like this is solved for A, D equals some other stuff. All right, so I'm going to find what's the variable. We're going to treat it kind of like a linear equation because I just want to get that by itself on one side to start with, right? So first step is get rid of fractions no matter what kind of equation you have. First step is get rid of fractions, multiply by that least common denominator. So we have 4a equals pi times d squared. Okay, then I'm still trying to get this d all by itself, so since it's multiplied by pi, let's divide both sides by pi. Okay, and I'm going to go ahead and write this d squared on the other side. I'm just going to flip these two just so that I have it in a form that might look a little more appealing to us. Okay, and now I've got the d all by itself. It's the only d in the problem. So hey, I can square root method that. So just remember, you got to have that plus or minus anytime you put a square root when you're solving an equation. And I can do that square root of 4, so I'm going to bring it out here. Okay, also remember from your radicals from your previous courses, you cannot leave a fraction under a radical. I believe in this section of homework they're letting you do that, but all right, so I'm going to change that to square root of a over square root of pi. All right, and then if I multiply by another square root of pi, as long as I do the same thing to the numerator and the denominator, it doesn't change the value of my fraction. It just lets me change what it looks like. So on the top, I can put these together as square root of a pi. And on the bottom, technically, I'm going to have the square root of pi squared, right? Pi times pi. But then that'll cancel. So we wind up with 2 square root of a pi all over pi. Okay, last thing, the discriminant. The discriminant is the part of the quadratic formula that's just underneath the radical. It does not include the actual radical sign, just the b squared minus 4ac. That's called the discriminant. That tells us a lot about our answer. Sometimes, for example, let's say our problem, and quadratic equations are really common in business, but let's say we're talking about a business application, and so it involves money. It would not make any sense to have complex values, right? Imaginary values for money. So it would mean it's a bad equation. So sometimes all I need to do is look at the discriminant to tell me if that's a valid equation for myself. All right, because it's what's under the square root, think about this. If you get a positive perfect square number, if there's a number underneath there, and remember what your quadratic formula looks like. It's negative b plus or minus the square root of that stuff that we're talking about, the square root of the discriminant, all over 2a. So if this was square root of 25, then I would just have this number plus 5 and this number minus 5. I would get two rational solutions, right? This number plus 5 over 2, this number minus 5, two rational solutions. If it's a positive number but it's not a perfect square, then that radical's not going away. And I'm still going to get 2 because I'm going to have the plus and minus, but this time they're going to be irrational. Would have like 3 plus square root of 7, 3 minus square root of 7. That square root isn't going away. If what's underneath here is 0, then the square root of 0 is 0, and really you're going to have 1 for all intents and purposes. There's 2 of them because you're going to have, let's say, 5 plus 0, 5 minus 0. Well, that's all still 5. So you're going to get 1 rational solution. If you get a negative number under this square root, you're still going to get 2 because you're going to have plus this and minus that, but they're going to be non-real complex solutions. All right, so I want to maybe keep up with this chart. And then this problem is just asking us to find the discriminant, right? And use it to determine the number of solutions and tell what kind they are. All right, so remember, our discriminant is just b squared minus 4ac, where this is a, b, and c. So b squared, negative 1 squared, minus 4ac. This is 1 minus 8, negative 7. Oh, that means we're going to get 2, I'm just going to say complex, right? Non-real complex. 2 complex solutions because this will be under a radical sign. Okay, so the discriminant is, the value of it is negative 7. It tells me there's 2 complex solutions. All right, here we go. A, B, C. So b squared minus 4 times a times c is 4 minus 20 minus 4. Well, there's 4 minus 4, so this is negative 20, which again gives me 2 complex. I'm going to check my answer on these just because I find it odd that they would give us, not show us the variety. So b squared minus 4ac, okay, b squared minus 4, oh, yeah, see, so be careful of your notation. This is so important. I'm going to just say I did that on purpose just to make a point, right? Okay, notation is important. This is 4 times A times C, right? Okay, so B squared minus 4 times A times C, which is 4. Now I've got two negatives, so that's plus. Okay, 20 times 4 is 80. So your discriminant value is 84. It's not a perfect square, so I'm going to get 2, right? It'll still be something underneath the radical, so 2 irrational solutions. Now in this one, I cannot use the discriminant unless it's set for 0. So don't make that mistake. Negative 25 is not C. Positive 25 is C. So be careful about that. All right. So B squared minus 4 times A times C. Okay, so that's 100 minus 4 times 25 is 100. So your discriminant value is 0, and because it's 0, that whole radical part of your equation will fall away, and in essence you're going to get one rational solution. There will be two of them. They'll just be the same number, because if you add 0 or subtract 0, you get the same value. Okay, I believe that does it for this section. Let me know if you have any questions, and I'll see you on the next round.